and good morning. I'm Wayne Churchill from the University of Illinois. I will be chairing this session. Actually, I spent 4 years at the University of Hong Kong as the Dean of Engineering. So I know this university quite well, and also work with many people here on the Area of Excellence program. The nano-electronic simulations that we have been doing in this university has been supported by AOE, or the Area of Excellence program. Professor Fuchun Zhang has been the principal coordinator of that program. Has been playing a very vital leadership role to put together principal investigators from Hong Kong U, Chinese University of Hong Kong, as well as HKUST, Hong Kong University of Science and Technology. Professor Fuchun Zhang, he was the department head of physics at the Hong Kong University, and he is also a chair professor at this same university. Let's welcome him to give the introduction.
Good morning. Much of today's program will be devoted to reporting to you some of our research program and our progress related to the Area of Excellence project. And so what I'm going to do is actually I will give so I will give an overview and a brief summary for the project. And then many of our LE members will report in great detail what they have been doing. We had a really wonderful session yesterday. We had 4 distinguished keynote speakers to give us get our idea what they have been doing and what's their view on this computational electronics. So what the purpose of today's program is to report to the audience, especially those experts, what we have been doing, and we'd like to hear their comments and suggestions for the next stage. So the project objective, that area of excellence is a part of the large research project in Hong Kong, supported by the Hong Kong government. And we were very lucky to get one of those. And that project usually lasts for 8 years with a midterm review. We just had a midterm review a few months ago. And our project started in January of 2010, so it's about 4 years ago. The objective is to develop the state-of-the-art computation tools for designing future nano electronic devices. So let me give a very brief introduction to the present team of the project. We have 8 PIs and about 10 co-Is from 4 institutes in Hong Kong, including University of Hong Kong, Hong Kong University of Science and Technology, and Chinese University of Hong Kong, and Polytech University in Hong Kong. So we have about half scientists and half engineers. So it's a very good combination and collaboration between scientists and engineers. And we have 5 research assistant professors and a dozen postdocs and over a dozen students. So those are the list of the PIs and the co-Is. I think all of the PIs and many of the co-Is are here. So the organization and the activities. We have Scientific Advisory Board, and those names actually we have newly added a few names there, including Gary Apri. That was initiated in 2009. And then we have AOE Management Board. Okay, we have initially 6 principal PIs, and later we added 2 new PIs for our new block to our AOE. And then we have 6 task groups, and led by different PIs. Okay. And you will hear their report. For instance, the first is about materials, and then this the chair of the session, Professor Wenqiu Chu, has been working on the EM. He is a world expert in fast organism in microwave. And Hong Guo, who will also give a talk today. Okay, it's this is the material, and another is atomistic modeling. And I'm in charge of spintronics, and then we have Philip Chen, and because he was later had a more important duty as the provost of PolyU, and he recommended Manson Chan, who has been playing a very important role to lead this CMOS. Then Guang Hua-Ching, who will be also giving a talk, who is responsible for the multi-scale problem. So we have 4 task groups. These are connected, and also each one will be responsible for certain things. And when Choi actually officially he has left this University of Hong Kong, he goes back to Urbana Champing. So we have a young new PI, Fuchun Zhang, who helped Wen Chu to continue to lead the group. So that's our organization. So that is initially the progress of the project. We have totally 8 years, and with the 4 years, right now we are in the stage. Okay, I will not go through these. Each year we have 6 task groups. Okay. Overall, we are pretty much in good shape to reach our goal until now. Okay. So that most important question is what is next for 4 years. And the major review, in our view, went very well. We will hear very soon, maybe in a few days, maybe in 2 weeks, the final result, or expect the project to be continued. Okay. So I will give a brief summary of some highlights of the area of excellence, the project achievement, and then I will leave all the detail to my members to report to you. Okay. And we have this tool for this non-perfect Green function, DFT, okay, for atomistic transport modeling benchmark against industry standard like Centrus and Synopsys. We have some advancement in EM solvers, and these innovations have attracted industry funding. And we have developed a simulation code for reliable generating amorphous high-K metal oxide, resolve a difficult issue in electronic material research. Some more highlights of the LE achievement. We have made major advances in both theory and experiment in pioneering exploration of very optical electronics in two-dimensional DMDC, and that is, I think, probably one of the most important science advancements within the project. And we will hear some experiment advancement along that line today. And we have developed the first principles simulation of AEC and time-dependent quantum transport, including numeric algorithms developed for modern transit current and AC quantum transport theory method has been established. We have also developed so-called QMEM, is quantum mechanics and electromagnetics method to resolve multi-scale issues in nano devices. More precisely is this is still in the testing stage, but we have some progress. Okay. And we have developed fabrication process suitable for our model calibration. That is mainly done in HKUST. They have a pretty good fabrication facility. And we have also launched web-based device simulator called iMOS. Okay. This is an online simulation platform for compact model and circuit simulation community. And also a center of gravity for AOE. So we different groups can use this on this web to communicate. So in the last 4 years, we have established very good or excellent collaboration between scientists and engineers, and between experimentalists and theorists, and between different institutes. Actually, that is not so easy. It was not so easy in Hong Kong. I remember when I came to Hong Kong about 10 years ago, each institute would like to compete each other. So I could not understand. I thought Hong Kong is small, we should compete with the world. Okay. And so that was the culture at that time, about 10 years ago. Now I think, of course, due to many people's effort, including the president level, and the different institutes are working together quite well. And example is within our AOE, I think we have very good collaboration among different institutes, as you will hear. And also like experimental series, and more interesting, I think actually to my also surprise, is series scientists and engineers. And that was, we had that kind of intention 4 years ago, and it turns out to be quite successful. And there are a number of examples. Here are just briefly list two of them. One example is nanoscale silicon devices with uniaxial strain. This is, I think, an important issue, as some of you, keynote speakers, discuss this issue, okay, or related things. So from the emerging transistor, this is an important issue. Okay, that initiated and worked out, okay, between scientists and engineers. I remember it was raised. The issue was raised by Philip Chen, who had experience in industry. Then the scientists initially did not realize this is an important issue, but they found that we could do that. Okay, so that ended with a good publication and still continue to work on that. Another example is this hybrid of expertise in atomistic method and EM solver and the circuit simulators. I think they are very good collaboration and achievement between scientists and engineers. And that method was initially to our mind, some of our mind, because we have very good expertise in EM solver, and we also have this expertise in atomistic method. We have been trying very hard to establish or to initiate a collaboration with the industry, and that is also not so easy. This time, the workshop is also try to establish or initiate our collaboration with industry, or to make our research relevant to future industry. Okay. And we have invited, these are some activities are listed here, invited advisors, industry leaders from Intel, Prof, TSMC, okay, and this time we have IBM, Intel, SMEE, okay, to visit Hong Kong. And we visited some of the companies like Macwell, Prof in Beijing, Macwell in Beijing. We have established a collaboration with Stanford and initiated such kind of possible collaboration with London's group in nanoelectronics. And we have had this AOE annual workshop on this simulation and modeling of emerging electronics with industry participation. So that is for the purpose to make all research related to industry's needs. We have co-organized the annual this EMD conference and hands-on workshop in China since 2011. And we have organized special symposium this year, IEEE International Conference on Electronic Device and Solid-State Circuit in Hong Kong. And we have a lot of very active visiting program to invite scientists, engineers, and those from industry to Hong Kong. So that would help us. So the future plan in the next 4 years, I think we would like to strengthen our connection to industry and also experimental groups. Okay. And one of the planned project is in connection with the London Center of Nanotechnology. And industry is also with the strength, the connection. And another thing is in the future 4 years, in the past 4 years, we have developed a lot of code, developed the method. So next challenge will be to develop software package. Okay. So that is our plan. So I think I shall. I give a summary. We will have 4 more years in the project, and in the following, I think our members will report to the audience, including several world-leading experts in the field, or work in some great detail, and we wish you will make comments and suggestions and possibly future collaborations. Thank you.
Are there any questions for Professor Zhang? Yes, Mark.
So I'm just I'm curious on some of the codes that you're developing. How do you plan to disseminate any of them open source or to the general community, or will they primarily be disseminated through this web interface?
Well, we have been discussing it. Probably it's likely to be the open source, if I understand. Yeah.
We actually have, in all of these codes development, you always have 2 sets of code. One is your research code. Student will touch and change. And then once this is matured, it's moved into some kind of official release of some kind. And so this is always done that way. And so we, this research code, anybody goes through, actually takes a copy away and so on. And this separate package, we're discussing how do we discipline. And this is a government-funded project, so it has to be disciplined.
Thanks for the introduction. So I'm just curious, how did you select these 2 particular device candidates, IMOS or the junctionless silicon transistor?
The IMOS probably is not.
Yeah, IMOS is because Manson has been working on that.
IMOS is not the impact analysis.
Oh, the IMOS is the iPad.
Oh, the iPad. Okay. Impact translation. Okay.
The junctionless is just we have some idea to test, and there are some experimental results on the junctionless transistor.
Okay,
Yeah.
they're already.
So just the experiment is there.
Mm.
So what we did is just test the theory of modeling simulation part. Actually, it's the simulation part is still much smaller than the real. It's like for test.
Okay, I guess we can also continue over lunch and over coffee break. Since we are running behind time, let's move on with the program. And, thank you very much, Professor Zhang.